Good morning or good afternoon and welcome to lesson 22 of module 4. Today we're going to continue with graphing proportional relationships, interpreting the slope, using y equals mx plus b, so our same standards EE5 and EE6. We're going to continue to work with those. Specifically, our objective for this lesson is that by the end of it, you'll be able to compare the constant rate between graphs, tables, and equations to determine which has the greater rate. And you'll know you're successful when you can observe, your graph, your table, your equation, and use mathematical reasoning to find either the slope, the constant of proportionality, or m, which all represent constant rate, and then compare them to each other, okay? We're going to do some review, some examples, exercises. We'll close out the lesson and complete an exit ticket. As always, keep in mind our class expectations. Your video should be on and you should be muted. You should be showing your thinking in your work. You should be responding to me in the chat when you work in breakout sessions. You should be communicating with your group members, sharing your ideas. Make sure you're having appropriate conversation. Communicate your technological issues to me, and just try to remain responsible, respectful, and safe at all times. Make sure if you have a class job, you're completing it. And as always, be thinking about how this lesson applies to your life right now in 8th grade, as well as your life beyond 8th grade. All right, so here's just a preview of what we're going to be doing today. We have a graph, and then we have a sentence that just kind of describes the situation. And what we're going to be doing is trying to figure out which one of these has the faster rate or the greater rate. So this graph below represents the constant rate at which Christina can paint. So if I'm looking in this, I see that we have down below time in minutes, and it's being compared to how much she painted. And this line represents her rate, so I can look for any point on this line. I see one right here, 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 and here. And I can line those numbers up with the y and the x values that go with it and find the rate by doing y divided by x. So for this first point, I have 4 as my y, 1 as my x. For the second one, I have, I think that's an 8 as my y, a 2 as my 10, etc. So any of these is going to give me the same rate because they're proportional. So I'm just going to start with the first one I had, which was 4 for my y. This is a y because this is a y-axis, and 1 for my x. So for this table, I'm going to do my slope, or my constant rate, is y divided by x, and in this case, my y was a 4, my x was a 1. Well, what is 4 divided by 1? This is 4. So for this graph, I know that Christina, her constant rate is 4 square feet in 1 minute. Okay, and we see that in 1 minute she can paint 4 square feet. And I want to see about her sister and see if she paints faster. So it says her sister Tracy paints an average of 45 square feet in 12 minutes. Assuming she paints at a constant rate, which paints faster? So she has 45 square feet in 12 minutes. So I'm going to be doing y divided by x as well. But I need to figure out what's the y and what's the x. Well, what was the y on the graph? Square feet. So this is my y value. And then our minutes is our x value. Remember, time is always independent, so time is always our x value. So I have 45 square feet divided by 12 minutes. And I'm going to go ahead and actually do this in my calculator to get a decimal, because it'll be easier to compare that decimal to the whole number rather than a fraction. So I have 45 divided by 12. And when I do that in my calculator, I get 3.75. So what does this mean? This means that Tracy paints 3.75 square feet per minute. So who's faster, Christina or Tracy? Well, Christina is faster. She has the greater rate. And why? 4 is greater than 3.75. So this is what we're going to be doing today. This was just a quick review of some things that we've learned in the past. Just kind of take this in, and we're going to move forward with our examples. All right, so for our first example, please write down everything that I write down. It says Peter paints a wall at a constant rate of 2 square feet per minute. Assume he paints an area Y in square feet after x minutes. So I'm going to go ahead and write this linear equation just with two variables. So what I'm going to do is I'm going to do y over x. Okay, got my two variables. And it says y is my square feet. Well, how many square feet does he paint? 2, so this is my y. Okay, and then my x is the number of minutes. Well, he paints in per minute. That means 1 minute. Okay, so what this shows me is that y divided by x equals 2. I'm going to rewrite it like this. And then I'm going to change this around a little bit. Okay, so just bear with me really quick. Y divided by x equals 2. So I have my linear equation in two variables, but I want my equation to say y equals mx. Okay, so I want to move this around a little bit. So I want the y by itself. Right now, I have my y being divided by x. So what's the opposite of divide by x? I'm going to times by x. I'm going to do it to both sides. Over here it cancels, and I'm left with y equals 2x. So this is my linear equation for this situation. Again, I just went and wrote out what I had and then changed that to follow this format. Okay, so I know that this is in the m position, so my slope or my constant rate is 2 square feet in 1 minute. Now it says sketch the graph of that linear equation. So I'm going to graph what I've just said. So it says he paints 2 square feet in 1 minute. So if I go to 1 minute and I go to 2 square feet, there's going to be a point right here. And I know that this rate is always up 2 over 1. Well, if I go up right to the next line right here, is that up 2? Yeah, I'm adding 2 to get there. And then I'm going to be going over 1. Is that adding 1? Yes. So this would be the same rate. And then I'm just going to keep doing that to find my line. All right, you can see that I went ahead and I just drew this line through all of those points. And now my question below wants me to answer, well, how much area does he paint in 8 minutes? So I'm going to go to time in minutes, and I'm going to look for 8. I'm going to see how much time, how much square feet does he paint in 8 minutes? Well, it lines up right there. Well, 16 square feet. Okay, next one. How much does he paint in an hour and a half? So an hour and a half, that's going to be, how many minutes is an hour and a half? Well, that's 60 minutes plus half an hour and 30 minutes. This is 90 minutes. My graph only goes up to 8 minutes. So how am I going to find this 90-minute mark? Well, it told me before that my minutes was my x. So all I have to do is plug this in for x, and I will have my answer. So y equals 2 times x, and in this case, I'm doing 90 minutes, right? I'm just going to do my multiplication. 2 times 90, 180. So in an hour and a half, 180 square feet are painted. And then lastly, I'm going to be doing 2 hours. Well, 2 hours is how many minutes? Well, 60 minutes is in 1 hour, so 120 minutes for 2 hours. And I'm going to be plugging this in. So y equals 2 times however many minutes, and it was 120 minutes. I'll do this math out. 2 times 120 is 240. So how many square feet will he paint in 2 hours? 240 square feet. Okay, and we're done with example number 1. Please make sure you have all this down. Okay, for example number 2, it says the figure below represents Nathan's constant rate of walking. Okay, so I'm looking at this graph. I can see that it's comparing time to distance, and if I find my points on this line, I'll be able to do some math. Y divided by x to find that rate. So if I'm looking at my first point that I found, I have my y and my x. My y is a 4, my x is a 1. So y divided by x is 4 divided by 1. Okay, well what is 4 divided by 1? 4. So this is my m. So if I wrote this out as equation, my equation would be y equals 4x, right? Y equals mx. Okay? A says, Nicole just finished a 5-mile walkathon. It took 1.4 hours. Assume she walks at a constant rate. Let y be the distance Nicole walks in x hours. So I'm going to be finding her rate as well. Okay? So y represents the distance. So what was her distance? 5 miles. And it took her an hour, or 1.4 hours. So x is my hour, so it's going to be divided by 1.4. And this is going to be her m. I'm going to do this on my calculator because it's just working with some decimals. So 5 divided by 1.4. And that equals 3.57, and it goes on forever. I'm just going to round off to 5.7. So this is her rate. And if I wrote this as an equation, it would be y equals 3.57x, because that's my m. Okay? Who walks at a greater speed? Who has the greater rate? Well, if I look at these both, and I'm looking at my rates, I have a 4 for Nathan. I have a 3.57 for Nicole. Who's faster? Well, obviously Nathan, because his rate is 4, and it is bigger than 3.57. So here's going to be my explanation. 4 is greater than 3.57. That's just my explanation. Pretty simple and to the point. Please make sure you have this down. Let me know if you're having any questions in the chat, okay? All right, for example 3, we're going to be doing the same thing. This time we have a table that we're going to be using to compare as well. It says Susan can type 4 pages of text in 10 minutes. Assuming she types at a constant rate, write the linear equation that represents the situation. Well, first we need to find and identify what's our x, what's our y. So remember, x is our independent variable. Y is our dependent variable. And if we're ever dealing with time, time is always independent of anything else, so that kind of helps us figure these things out. So I am dealing with time here, so I know that 10 minutes, this is my x, okay? So that means that 4 pages is my y. All right, from there I'm going to write my linear equation, so I'm going to do y divided by x to get my m. So 4 divided by 10. And if I turn this into a decimal, 4 over 10 is the same as 4 divided by 10. This is 0.4. So this is my m, or my constant rate. So now I'm going to write my equation in y equals mx form, knowing that this is my m. So y equals 0.4x for this little relationship. Okay? B says the table of values below represents the number of pages that Anne can type y in a few selected x minutes. Assume she types at a constant rate. So for this, I'm going to be doing the same thing, y divided by x, to find her constant rate. I can choose any values I want here. I'm going to choose my 2 and my 3 because the other ones look crazy. They're crazy fractions, so it's going to be 2 for my y. Remember that this is our y, divided by 3 for our x. And if I turn 2/3 into a decimal, which I'm wanting to do because my other number was a decimal, 2 divided by 3 is 0.66 repeating. Okay, so this is my constant rate here, and I'm just going to write that into an equation. Y equals 0.66 repeating x. So I have these 2 equations, and I'm going to be comparing them, saying who types faster? Well, who has the bigger rate? 0.4 or 0.66? Well, remember, with decimals, they go on forever, so if I wanted to fill this in with a 0, I could. So 0.40, 0.66, which is bigger? 0.66. So who is faster? Anne types faster. And why? Her rate is 0.66, pages per minute. And Susan's is only 0.4 pages per minute. All right, and that is my answer. All right, our new learning for today is honestly not that new. It's just kind of combining some things we've already learned. So we can compare the rates of graphs, tables, and equations by using their constant rate. So from a graph, we find the constant rate by either finding the rise or the run over the run, or we can just find a point on our graph and do our y divided by our x. So in this case, it would be 3 divided by 4. So 3 divided by 4 in this case is 0.75. So for this graph, my rate is 0.75. Okay? If I was using a table, I would do the same thing. Y divided by x. It's just a lot clearer to see. And in this case, I have 3 divided by 2. And if I divide that out, I get 1.5. So my m for this equals 1.5. Remember, m means constant rate. And then for an equation, if I have an equation written, I know that whatever falls in the m position is my constant rate. So my m here is 1.3. Okay? And if I were comparing these 3 different modes, these 3 different unit rates, which one would be the greatest? 1.5. Why? Because that's the greater rate. That's my greater constant. Okay? All right, for exercise 1, you are going to do with your group. It says Phil can build 3 birdhouses in 5 days. Assuming he builds birdhouses at a constant rate, write a linear equation that describes the situation. So you're going to be doing y divided by x. Remember that time is our x, and whatever is the other number is our y. So please do y divided by x to get your m. And then on the second part, it says the figure represents Carl's constant rate of building. Who builds faster? We'll go throughout Carl's graph, find some points, and do the same thing, y divided by x. Okay? And we're going to go over this in about 2 to 3 minutes. All right, so for number 1, I have 3 for my y, 5 for my x, and if I change this to a decimal, 3 over 5 is the same as 3 divided by 5 in my calculator. I get 0.6. So this is my m. This is my constant rate. So if I were to write this equation out in y equals mx, this would be y equals 0.6x. Okay? For the graph down below, I'm going to do y divided by x. I have 3 divided by 4. Remember, this is my y, this is my x. Well, 3 divided by 4, my calculator is 0.75. So this is my m, or my rate, for this graph. And if I were to write that as an equation, it would be y equals mx. So y equals 0.75x. Well, when I'm looking at these 2 equations, which one has the greater rate? 0.75 or 0.6? 0.75. So who builds birdhouses faster? Carl does. And the reason being is that 0.75 is greater than 0.6. He has the greater rate. Okay? That's my answer for exercise number 1. All right, exercise number 2. Please do this with your group. It says Natalie can paint 40 square feet in 9 minutes. Assume she paints at a constant rate. Write the linear equation. Remember, minutes is time, so this is our x. This is our y. So please find y divided by x. Okay? And then it says the table of values below represents the area painted by Stephen. I would choose this first row and just do y divided by x because it's the only row that doesn't have a fraction. Okay? And then at the bottom, please tell me who paints faster and explain why. All right, going over this, I have 40 as my x, as my y, oh my gosh, and 9 as my x. 40 over 9 is the same as 40 divided by 9, and when I do that in my calculator, I get 4.4 repeating. So this is my constant rate for exercise 1. And if I wanted to put that in equation, I could. It would be y equals 4.4 repeating x. Okay? For the second one, for my table, I have y is my 10 and x is my 3. And if I do 10 divided by 3 in my calculator, I get 3.3 repeating. So that's my constant right here. If I wanted to put this in equation, it would be y equals 3.3x. Okay? Which one paints faster? Clearly, 4.4 repeating is faster. So this was Natalie. And the reason being, she paints 4.4 repeating square feet in a minute. And this other girl, who's this other? Oh, this is Steven, not a girl. Steven paints only 3.3 square feet in a minute. All right, please check your work with my work, and we're going to move on to exercise number 3. All right, exercise number 3 says Bianca can run 5 miles in 41 minutes. Assuming she runs at a constant rate, write the linear equation that represents the situation. Okay, I'm not going to help you out at all here, so you need to identify what is y, what is x, and then do y divided by x to find your constant. And then it says the figure below represents Cynthia's. Please do y divided by x for her, and then tell me who runs faster. Okay? All right, the first thing I needed to do was identify my x and my y. I know that time is always independent, so this is always going to be my x. And then whatever else is left is going to be my y. So here I have y divided by x. It's going to be 5 divided by 41. And if I do that in my calculator, 5 divided by 41 is 0. It's a long decimal, but I'm going to round it off to 0.12. Okay? And it wants me to write that in a linear equation, so it's going to be y equals mx. Well, my constant rate is 0.12. So this is my equation here. Okay? The one below is a graph. I'm looking for a point. I see one point right here. And this point matches up with these two values. I have 1 for my y, 7 for my x. So 1 over 7. If I do this out in my calculator, 1 divided by 7, I get 0.142 something. I'm just going to round it off to 0.14. So this is my constant rate, and it wants me to write it in an equation. Y equals 0.14x. So this is my equation. Okay, now looking at these two equations, which one has the greater rate? Well, this first one for Bianca, she had a rate of 0.12 miles per minute. And this one below, Cynthia, she has a rate of 0.14, 0.14 miles per minute. So who is faster? Obviously, Cynthia. And the reason being is that her rate, 0.14 miles per minute, is greater than 0.12 miles per minute. And that's my explanation here. Make sure you have this down before we move on to our closure and exit ticket. All right, for our lesson closure, we just want to know we can compare the rates of graphs, tables, and equations by using their constant rates. For a graph, we find our constant rate by doing the rise over run. Remember, this is the same as y divided by x. So for a graph, we just find what matches up with our y, what matches up with our x when we're graphing this line. Okay, we find a point. We say, oh, here's my x, here's my y divided by x. Okay? For a table, super simple because it's usually always written out for us. So we would just always do y divided by x to get our constant rate. And then in an equation, we usually are writing these equations for this lesson, but that is just our m. Whatever our m is, whatever our slope is, that is our constant rate. A couple things I want to remind you of. Constant rate is the same thing as slope. It's the same thing as unit rate, and it's the same thing as constant of proportionality. So these things all go by the same, well, it's the same thing that all goes by different names. Okay? If you're feeling confident with this, please move forward to the exit ticket. If you're not, let me talk about the exit ticket for you, but then before you do it, go back and rewatch some of these examples and exercises. All right, your exit ticket for today, it says water flows out of pipe A at a constant rate. Pipe A can fill 3 buckets of the same size in 14 minutes. I'm going to help you out a little bit here. Your minutes, that's your time, so that's your X. And your 3 buckets, this is your Y. What I want you to do is find Y divided by X. Okay? And then I want you to write your equation Y equals mx. Obviously, you're going to write whatever m comes out to when you do your solving over here. Okay? And then down below, the figure below represents the rate at which pipe B can fill the same size buckets. I want you to go through. You have a point here. You have a point here. It does not matter which one you choose, but please find Y divided by X. Okay? And for this one, it doesn't tell you to write the equation, but I still want you to write the equation. I want you to get in the habit of that. So whenever you find m, tell me what m is by putting it in that little box. And then down below, tell me who or which pipe fills buckets faster, and please explain it. The explanation does not have to be super long. It just reminds me that you know why this is your answer. You're not just guessing, okay? When you're done with this, please do your lesson reflection in Google Classroom.